Okay, so let's go step by step on how to run Ollama, and then we'll talk a little bit about tuning your results and what that means. So you've gone to ollama.com. You clicked on download. You've installed it for Mac, Linux, or Windows. And now you have your little Ollama icon running here, and you've got a terminal open. The first thing you do is you go to models. You select a model that you want to use. You know, I think I want to use a 3 billion parameter llama model. So this one's pretty common, runs on a lot of computers really well. You select 3 billion here. Then you copy this little command. And then you just paste Ollama run 3.2 3 billion. And it's available. If you don't have it, it will download it for you. Then you'll send in your prompts. Tell me about how to make dairy-free ice cream. Right? And it shows you how to make dairy-free ice cream. Great. So this is pretty basic stuff. If you want to delete a model, you can delete it. And you type in /by to leave that model. You type Ollama list to list the model. Now, I mentioned that I could not get this 405 billion parameter model to run, right? This thing is just too much for my computer, too much for any computer I have. So if you just type in Ollama, it'll tell you how to help, and you can say Ollama serve, create, etc. Most of these you don't really need to worry about. You just need to worry about Ollama run and maybe Ollama list, right? But how about remove a model? I've decided I don't really like this much, so I'm going to do Ollama RM. I've copied that, and I'm going to remove this 405 billion parameter model. It's way too big. Machine won't run it. I go to Ollama list, and here's my list of currently available models. And like I said, if you don't have the model, Ollama run will run it if it's on your machine. If you don't have the model, it will download it. Like we can just go to, here's one that I know I don't have a PHY model here. So I'll select 14 billion. That sounds good. I'll copy it. Go back to my terminal. And now it sees that I don't have it, so it's going to download it as we go. This is the basic usage of Ollama, right? This is just kind of the basic download a model, run stuff against it, exit it, etc. Like I said, you can write Python against it really well. It's kind of outside of the scope of this course because I just wanted to show basically how to run these on your own machine. But I do want to show you a little bit of fine-tuning stuff, and we'll do that after this downloads. All right, I didn't want to make you sit and wait through this whole thing. So it's downloading, and once it downloads, it'll automatically load up. And now we have Phi or Phi loaded up. I'm not even sure how this is pronounced. So I can say, tell me a funny joke. Why don't eggs tell jokes? They might crack up. Awesome. Yeah, like I said, jokes are always terrible. So we'll type in by. Okay, so now you basically know how to download a model, interact with it, etc. with Ollama. Now, type in Ollama list, and I'm going to load up a llama model. One of the cool things about llama models is they're very tunable. So we're going to talk about a little bit about fine tuning. We're not going to get really deep into this. There's definitely some levels of this that are very confusing for new folks, but we can play around with it a little bit, right? So we're going to say Ollama run this, and then I'm going to type in -- verbose at the end. And what that's going to do is give us a little bit of statistics at the end of each run, and it's just going to be more chatty, right? So you say, tell me a funny joke. What do you call a fake noodle? An impasta. And it shows you the duration, the load, evaluation count, etc. These things might be important to you later down the road, so I just wanted to show that feature. Now, when I type in clear, it doesn't doesn't clear the screen. That's fine. What we're going to do here is, let's say we write an article. Say write an article about heartworm for dogs. We let this thing go. This is just at the standard temperature with all of the standard settings. But what if you want things to be a little bit more creative? Whoops, and my thing closed. So what if we want to be a little more creative with it? Well, we can do some fine tuning on these models that will change the outputs. Now, none of this stuff is really drastic, right? But sometimes you just want to kind of say, I think I want this to be more creative. I want this to be more rigid. And temperature is one way to do that. So with the temperature of the model, increasing it will make it more creative. It'll make it make up more things. So if you set the temperature to be very low, it's going to be exact and it's going to try to be as accurate as possible. And if you set the temperature higher, then it's going to try to be more creative. Now, the default is a 0.8. We can set it really low just by typing in set parameter. Would help if I spelled it wrong. Temperature 0.1. And it's from 0 to 1. And I forgot to put in the front slash. There we go. Now we've set the temperature to 0.1. So if we write an article about heartworms for dogs, it's going to be very factual, very rigid, kind of looks the same as what we did before. If we want it to be more creative, we would do set temperature of 0.9. Now the same article is going to be a little more creative. It's going to be less rigid. There are some caveats to that. It's going to basically hallucinate more, for lack of a better term. Let's use a different example for this. I can say the sky is, and see what it auto-completes. Blue. Or is it? Depending on where you are in the world, the sky can take on many different colors at various times of the year. But when we think of a typical clear blue sky, that's often what comes to mind, right? So this is basically just trying to predict what you're going to say. So if we set the temperature to 0.1 and say the sky is, now it says gray, maybe shade of pink or orange or sunset, etc. Well, usually when I do that, it just puts out blue. But as I can see now, it's making up different things. This is the nature of large language models, unfortunately, is that they're very unpredictable. They're not deterministic in any way because they're basically statistically generating the best answer to your question. So let's see if another good way to measure temperature. Why don't we ask the model, what is a good prompt that will show the effects of setting temperature on a large language model? Let's see if it will suggest something. Ask the model to engage in simple conversation. We'll start that first one. Ask the model to engage in a simple conversation, such as discussing the weather. Ask it to repeat the conversation with a different temperature setting. Okay. What is the weather like in Oregon? This isn't very conversational at all, right? It talks about the weather, and then it suggested in here, can you have this conversation again, but with a 50% lower temperature? And we are set at 0.1 right now. I'll do my best to simulate a 50% lower temperature setting. Now we'll do set parameter temperature at 0.9. And I'll say, can you have this conversation again, but with a 900% increase in temperature? Let's just play around with it. That's another good thing about these local models, is you can do whatever. Now let's see what it shows us. This is going to be a little different. So before, seasonal weather patterns around 20 degree Fahrenheit. Yeah, average high at 20 degree. I don't know if that's true, but at least not my part of Oregon, with snowfalls common in the mountains, etc. Now, when we pump the temperature way up, the coastal region has a mild oceanic climate with temperatures ranges from 1400 Fahrenheit in winter to 5300 Fahrenheit in the summer. It gets very hot. Expect plenty of volcanic ash and fire rainbows, especially during the summer months. The Willamette Valley, that's where I live, has a more moderate climate of 2200 degrees Fahrenheit. So this was actually a good suggestion here to show kind of what temperature does. So when you set temperature, you do the set parameter temperature from 0.1 to 0.9 will give you a little less drastic result than this, but you can see Eastern Oregon, 2300 degrees Fahrenheit. So what do we learn from this? That if we set the temperature very low, it's going to be rigid. That weather report's pretty accurate. It's going to say this is the weather. If we set the temperature to be high, then it's like, oh, well, I'll just make up some stuff and see how that goes. Where is that cool? Like, where is that something that we want to do? You want to set the temperature higher for more creative things. If you're doing creative writing and you say, please be more creative with X, higher temperature is better. If you're doing things like poetry, songwriting, you don't want those to be super rigid and follow a bunch of rules. You want them to be a little wild and a little all over the place. So I think this was a good example. In the numbers, you can tell are just way out there. You know, it's 45,000 degrees Fahrenheit today, but you know, not usually, or whatever. It says cacti are the only vegetation left standing. The Cascade Range, more extreme climate, temperatures so hot that glaciers are just a myth, etc. It's just a way to increase the creativity a little bit. And there are some other ones like top P, top K. There's a whole list of model file parameters here that are generally available. As you can see, there are a ton of fine-tuning options. I don't think we should cover that in this course, but if there's interest in the community, I will cover it in a future course to where you can do some fine-tuning of different outputs that come from Ollama. And you can see there's a bunch of stuff. Seed is probably the one that I use the most. So it sets a random number seed to use for generation. Setting this to a specific number will make the model generate the same text for the same prompt. So I do use this seed quite a bit if I'm trying to follow a thread of things and I want it to be pretty much the same. Seed is pretty good, but I just kind of wanted to give a brief glance of what fine tuning looks like. It's a whole lot of set parameter X. The Llama models tend to be very good at fine tuning and things like that, but I hope this is kind of giving you an idea of how to use Ollama, how to load up a model, how to run some stuff against it. Next, we're going to check out LM Studio, which is a little more user-friendly, a little more graphical than this text thing, and let's dive into it.